By the early 2000s, the most controversial piece of iron on an American job site was not painted yellow or orange, it was green. Introduced in 2003, the John Deere 9620 articulated tractor was rated at 375 engine horsepower, and it weighed over 43,000 pounds. It was designed to pull the largest tillage tools in North America. On paper, it was a monster, the peak of Deere's four-wheel drive lineage. But inside the engineering circles of Iowa and Wisconsin, another machine was being whispered about. It was built not by a corporation, but by one man, Jon Kinzenbaw, a former Deere engineer, who believed the future of traction did not belong to rigid frames or to traditional articulation. A 2002 dealer bulletin praised Deere's drivetrain durability. A 2004 Successful Farming Profile quietly asked why Kinzey's radical tracked prototype was outperforming factory iron in wet fields. Two visions, one market, one company with everything, and one man with nothing to lose. How did John Deere, the most powerful name in agriculture, lose a war it never thought it was fighting? By the late 1990s in Waterloo, Iowa, John Deere was the unquestioned authority on row crop power. The Waterloo Tractor Works, employing thousands across multiple shifts, produced machines that defined reliability across the Corn Belt and beyond. Dealers trusted the brand without reservation. Farmers financed green iron the way they paid property taxes, inevitably, predictably, with confidence born from decades of dependability. Industry reality was conservative by design, shaped by risk-averse operators and cautious lenders. Articulated four-wheel drives dominated high-horsepower farming, their twin-frame architecture considered the pinnacle of traction engineering. Tracks were seen as specialty tools, expensive, maintenance-heavy, and risky for resale value. A 1998 Deere dealer manual emphasized resale value and serviceability over radical innovation, reflecting market preferences shaped by banker requirements and operator skepticism. Operators echoed the same sentiment in trade surveys and at coffee shop tables. Uptime mattered more than novelty. Proven design trumped experimental engineering. Deere did not chase disruption. It was the standard everyone else measured against. The problem with being the standard is that standards invite challengers willing to risk everything. Jon Kinzenbaw grew up in Williamsburg, Iowa, surrounded by farms that punished weak equipment and rewarded only what worked season after season. After earning an engineering degree, he joined John Deere in the 1970s, working on drivetrain and chassis concepts in the same Waterloo facilities that built the company's reputation for mechanical excellence. Former colleagues recalled him as precise, stubborn, and deeply field-oriented, an engineer who spent more time in mud than in meetings, who trusted operator feedback over computer models. An internal engineering memo from the 1980s referenced Kinzenbaw's concerns about soil compaction and power loss in articulated tractors, concerns that never made it past review committees to production floors. The issues were acknowledged, then buried under operational priorities and quarterly timelines. By 1987, frustrated with corporate inertia, Kinzenbaw left Deere and purchased Kinze Manufacturing, a struggling planter company based in Williamsburg. His early success rebuilding Kinze planters through practical innovation established credibility with farmers who valued function over brand loyalty, performance over paint color. He learned Deere's rules, and where they refused to bend, Kinzenbaw wasn't leaving the industry. He was waiting for the right moment. By the late 1990s, Midwestern farms were growing larger, heavier, and wetter with each passing season. Spring planting windows tightened as weather patterns shifted. Articulated tractors struggled with compaction on saturated ground, and their articulation points created pressure spikes that damaged soil structure. Duals tore soil in turns. Horsepower increased year after year through turbocharging and displacement, but usable traction did not follow proportionally. Trade publications such as Farm Industry News and Implement and Tractor documented rising complaints about yield loss due to compaction in wheel tracks, losses that precision agriculture was making increasingly measurable and undeniable. Deere acknowledged the issue in technical bulletins, quietly, but stayed within conventional design language. Tooling investments were massive, measured in tens of millions. Dealer training was expensive and time-consuming. Existing customers still bought wheeled tractors by the thousands every year. Kinz's planter customers, the very farmers who trusted Kinzenbaw's previous innovations, felt the pain firsthand every spring. Wet springs meant delayed planting. Delays meant lost revenue and missed market windows. Compaction meant reduced yields in precise, measurable patterns that persisted for years. The market knew the problem, and the incumbents knew the risk of solving it. Innovation does not begin with technology. It begins with irritation that will not go away. In 2000, inside a repurposed manufacturing facility in Williamsburg, Kinzenbaw began assembling a prototype. No major original equipment manufacturer would approve. A tracked, rigid-frame agricultural tractor using surplus, military-grade track systems, adapted for soil engagement rather than battlefield mobility. The design eliminated articulation entirely, challenging decades of accepted traction engineering wisdom. 4 independent tracks distributed weight evenly across a footprint conventional machines could not match without doubling their wheelbase. The prototype weighed over 50,000 pounds fully configured, but exerted lower ground pressure than Deere's wheeled machines on comparable tillage tasks, a paradox that defied operator expectations. A 2001 patent filing described Kinzenbaw's track geometry and suspension logic in technical detail, focused entirely on soil preservation and tractive efficiency, not ride comfort, highway speed, or operator convenience. It was not elegant. It was unapologetically functional, brutal in its honesty about what mattered in wet field conditions. Deere had laboratories full of people with doctorates and computer simulations running thermal and stress analyses. Kinze had a shop floor, a welder, and conviction born from decades of watching good operators struggle with inadequate tools. The first machine looked like it had been assembled from 3 different tractors, because it had been, using salvage components and custom fabrication. Early demonstrations in Iowa cornfields during the spring of 2001 drew crowds of skeptical operators and immediate ridicule from conventional engineers. Dealers doubted serviceability in their existing infrastructure. Farmers doubted resale value in markets that had never seen anything like it. The machine looked unfinished, industrial, almost crude compared to the sleek lines and refined styling of modern Deere iron fresh from Waterloo. Banks questioned the collateral value. Insurance companies struggled to classify it. An operator quoted in Successful Farming recalled that it looked wrong until you pulled with it, then everything else looked wrong. Under load in saturated soil, the machine refused to sink, its tracks distributing weight across a surface area that conventional designs could not approach. Slippage dropped dramatically compared to wheeled tractors on identical soil conditions. Measurements confirmed what operators could see in the field. Fuel efficiency improved in wet conditions because power was not wasted spinning tires or fighting articulation resistance. Side by side, comparisons were not close. They were embarrassing for conventional designs, revealing decades of accepted compromises. Farmers who watched the demonstrations did not need engineering degrees to understand what they were seeing in the mud. Performance does not ask permission. The machine did not need belief, just a field and a skeptical operator. Inside Deere's sprawling Waterloo complex, engineers tracked Kinze's progress through dealer reports, operator feedback, and field observations conducted quietly through third parties. In 2002, an internal Deere analysis referenced non-traditional track architectures as a potential competitive threat requiring monitoring and strategic assessment. Technical committees debated response options, but Deere's scale worked against urgency in ways small companies never experience. Tooling costs for a radical redesign ran into tens of millions of dollars. Dealer retraining programs were expensive and time-consuming across a network spanning thousands of locations. Existing customers still bought wheeled tractors in volume, generating reliable revenue streams. Quarterly earnings calls did not reward preemptive disruption. They punished unstable product lines, experimental investments, and unproven market segments. Engineering committees debated merits, Marketing teams studied operator demographics and buying patterns. Finance departments modeled risk scenarios and return timelines. The machine worked exceptionally well in Iowa field conditions, but would it work in dealer networks across 48 states with varying soil types, climates, and operator preferences? Big companies do not fear failure in laboratories, they fear instability in markets. By the time data proves disruption is real, it is already too late to respond effectively. In 2002, Deere responded with the 9420T tractor, powerful, familiar, fundamentally conservative in its engineering approach. It retained articulation, preserving decades of drivetrain engineering and operator familiarity. Tracks were essentially bolted onto known architecture, minimizing tooling investment and dealer retraining requirements while accelerating time to market. Specifications impressed on paper: over 425 horsepower from proven Deere engines, familiar control layouts that required minimal operator adaptation, and parts compatibility with existing inventory. Dealers felt safe selling it to conservative customers. Service departments understood it without extensive training. Marketing materials emphasized evolution, not revolution. But side by side, field tests in identical wet spring conditions told a different story that brochures could not hide. Compaction remained uneven under articulation, stress points where frames joined. Turning radius scrubbed soil in ways rigid frames did not, damaging structure. Operators noticed immediately. Agronomists measured the differences with soil penetrometers. The engineering was sound, it just was not revolutionary, not willing to abandon the comfort of proven design. Deere engineered caution, betting that brand loyalty and dealer infrastructure would matter more than raw field performance. Kinze engineered defiance, betting that performance would overcome every disadvantage of scale, distribution, and market acceptance. Two tracked tractors, two philosophies, one winner. By 2004, Kinzenbaw introduced the Kinze 1000, rated at 450 horsepower, built in strictly limited numbers in the Williamsburg facility. Each unit was assembled almost by hand, with quality control procedures that resembled aircraft manufacturing more than agricultural equipment production lines. Components were inspected multiple times, tolerances were tight, assembly took weeks per unit, dealers were bypassed entirely, a radical decision that eliminated traditional distribution channels. Kinzenbaw sold directly to operators willing to bet on unproven iron, farmers who understood what they were buying and why. Financing was personal, often structured through regional banks that knew the farmers individually, understood their operations, and trusted their judgment over standardized credit formulas. Risk was absolute. No dealer network meant no parts infrastructure, no factory-trained service technicians, no established resale market, no trade in values. Operators who purchased the machines described the experience as transformative, a fundamental shift in how they approached wet field conditions, quieter soil engagement, unmatched pull, and conditions that stopped conventional machines cold, compaction measurements that defied expectations and challenged agronomic assumptions. Innovation scaled slowly. Production was measured in dozens, not thousands, but belief spread fast among the high acreage operators who mattered most. Deere sold thousands annually. Kinze sold proof. The Kinze 1000 became a legend in the tight circles of high acreage operators across Illinois, Iowa, and Indiana. Photos from 2005 Illinois job sites showed it dwarfing implements Deere struggled to pull efficiently in challenging spring conditions. Weight exceeded 60,000 pounds when fully ballasted for deep tillage work. Yet soil compaction tests using standardized penetrometers consistently favored Kinze's distributed load geometry over articulated designs operating in identical conditions. The measurements were not close. They revealed fundamental advantages in weight distribution that conventional engineering had accepted as impossible. Engineering publications called it impractical, too heavy, too specialized, and too expensive to service outside established dealer networks. Farmers actually using the machines called it unfair, an advantage so pronounced it felt like cheating, like discovering everyone else had been playing by unnecessarily restrictive rules. Trade press coverage oscillated between technical admiration and commercial skepticism. Agricultural engineers praised the innovation. Business analysts questioned the sustainability. The machine worked brilliantly. Performance was undeniable. But could a company the size of Kinze support a product this complex long term? Could they build parts inventory, train service networks, and establish resale markets? Being right does not mean being safe in agriculture. That is when the giants move, not with innovation, but with infrastructure. Deere responded with expanded track offerings, aggressive financing packages that made capital costs manageable, and dealer incentives that made green iron irresistible on paper to risk-averse operators. Parts availability favored machines with nationwide networks, overnight delivery instead of waiting for custom fabrication. Service infrastructure became the real battlefield. Resale markets punished outsiders systematically because used Kinze tractors had no established value guides, no dealer trade-in programs, no financing options for secondary buyers, and no auction history to establish market confidence. Banks would not finance them as collateral. Appraisers could not value them. Service became the decisive factor, not performance. A Deere breakdown meant calling a dealer 20 miles away with parts in stock and factory-trained technicians available. A Kinze breakdown meant calling Williamsburg directly and waiting for custom solutions. Operators betting their entire spring planting window on one machine, with weather windows measured in days, could not afford that risk, regardless of field performance advantages. Kinzenbaw knew this reality. He could not fix it without billions in infrastructure investment. Markets do not reward brilliance alone. They reward infrastructure, scale, accessibility, and the ability to support products across decades and thousands of locations. The best machine still needs a dealer at midnight during planting season. By 2008, the recession crushed capital purchases across agriculture with brutal suddenness. Credit tightened as banks retreated. Equipment orders collapsed nationwide. Farmers delayed upgrades, nursing older machines through additional seasons. Dealers cut inventory to preserve cash flow. Kinze, already operating on thin margins with limited production volume and high per-unit costs, could not absorb the shock. Revenue disappeared. Fixed costs remained. The tractor program was sold to Bueller Industries, which operated under the Versatile brand in Canadian markets. Production ceased shortly after the acquisition as new management assessed viability. Engineering drawings were archived in file cabinets. Tooling was dismantled and sold for scrap value. The Williamsburg facility returned to planter manufacturing exclusively, the core business that had sustained the company before the tractor experiment. Deere endured the recession through diversified product lines, global dealer networks, financial reserves, built over decades of profitable operations, and access to capital markets smaller companies could not reach. Kinzenbaw returned to planters, the business that had made his reputation and that farmers understood and trusted. The war ended without surrender, without victory, without clear resolution. There was only exhaustion, brutal market timing, and the economics of scale revealing themselves. Innovation does not always die. Sometimes it simply migrates, waiting for better conditions. Kinze tractors vanished from dealer lots, farm auctions, and equipment listings with surprising speed. The machines that remained in operation became curiosities, functional but orphaned, maintained by owners who fabricated parts, adapted components from other brands, or stockpiled spare assemblies. Online forums documented creative solutions and improvised repairs. Deere's tracked machines improved incrementally over the following years, each model generation incorporating subtle refinements to weight distribution, ground pressure management, and rigid frame geometry concepts. The innovations were not credited to Kinze in marketing materials or technical bulletins. They did not need to be. The ideas had become industry knowledge, absorbed into the collective engineering understanding. Farmers who had operated both machines remembered the differences clearly. Engineers who had studied the field tests remembered the measurements. Academic researchers cited the patents in soil compaction studies. The idea survived and spread, even as the name faded from catalogs, trade journals, and dealer signs. Legacy does not need logos or brand recognition. Sometimes it just needs to be right. Today, a Kinze 1000 sits deteriorating on a Midwestern farm lot. Paint faded to primer gray, tracks stiffened by years of weather exposure, hydraulic lines cracked from sun and cold. The future it promised is now standard across the industry. Distributed weight, rigid frames, advanced track geometries, computerized traction management, just painted green, yellow, or red by companies with the infrastructure Kinzenbaw never built and could not afford. Sati, Deere, Case IH, all produce tracked tractors that owe technical debts never acknowledged in marketing campaigns. The machine still stands, weeds growing around its tracks, a monument to engineering conviction and market reality standing side by side in the same rusting frame. The field still remembers what it could do, how it refused to sink when everything else did. Only the badge is gone, the name faded. If the industry ends up where the innovator stood first, did the innovator lose, or did everyone else just arrive late?